Hello, good evening, friends. This is again Shivakkumar, actually sharing radio frequency identification technology or RF actually in my second video. This is my second part of the video, and in first video I have shared about the say we have many yeah, I mean actually the details covering when the RF was introduced and then introduction to RFID, RF devices, and then barcode functionality, and then barcode format, and then manufacturer's code and product code, and check digit. So International Article Numbering Association EAN, and then this difference between the RF and RFID, and then how you can use RF in your warehouse, and then guide devices and character based devices, and SAP console, telnet, and web server. Then we discussed about what are the application areas in warehouse for which the RF is used. GRJI, put away, picking, packing, unpacking, PA, physical inventory, loading, unloading, serial number capture, stock overview, and then RF monitors, and then how one can use RFID in a warehouse, and then supported functions in AutoID infrastructure, and then outbound processing, right? And then flexible delivery processing and returnable transport packaging items RTA. And actually this diagram already told actually the integration of RFID landscapes. So as already told, device controller are the software components and integrator is a hardware component, and the software component device controller which will integrate the hardware part, that is integrator of RF device to the SAP AutoID infrastructure. So the communication will take place through the device controller. So now let's move on to the next part of the video. So RFID technology, okay. So I already told RFID is already available for the decades, but recently we have to push its usage into many platform oriented applications, inventory, and then actually for the say for example GIGR, all these things, and say normally large companies like Reliance, Walmart, Target, so all these brands of retail companies, they are including the RFID to reduce the warehouse cost and improve the supply chain efficiencies. I already told that. So every industry, that is publication, as an article and commentary on the radio frequency identification, right? So, however, um, yeah, however, it is not a new technology. So, sorry guys, yeah. The first use of RFID was documented in the 1940s by the British Royal Air Force to identify the aircraft in the World War II, and was a part of the refinement of the radar. Okay, it was during 1960 that RFID was first considered as a solution for commercial world. Only I think already I have discussed in my first part of the video. The first commercial applications involving RFID were developed throughout the 1970s and 1980s. Okay, these commercial applications were concerned with identifying material includes the single location. Okay, so the last attempt to the commercialize the use of RFID structured in 1998. Okay, when the researchers at the Massachusetts Institute of Technology (MIT), right? So Auto ID Center began to search new ways to track and identify the objects as they moved between the physical locations. This research centered on an radio frequency technology and how information that is held on tags can be effectively scanned and shared in the real time. So RFID is known today as a reading of physical tags on a single products, cases, pallets, and reusable containers that emit the radio signal to be picked up in the RFID reader devices. Industries see this technology as a way of identifying material more accurately than with the traditional means. The, and this video will give you the understanding of the technology behind the RFID, the history of the technology, the development of the technology into a commercial applications, and where the applied technology is used within the frame of SAP and the warehouse management. So, introduction of radio frequency is a simple starting, that is it means an identifying an object using the radio frequency transmissions. The technology can be used to identify, track, sort, or detect a wide variety of objects. Communication takes place between the reader or the integrator and a transponder or a tag. Okay, the tags can either be active, that is powered by the battery inbuilt, or a passive powered by the reader field. Okay, a reader field is an RF field that is transmitted by the reader to the to interrogate the RFID tag. The communication frequencies, right, used depend to a larger extent on the applications. They range from 135 kilohertz to 2.545 gigahertz, that is a wavelength, okay, frequency wavelength. Most of the countries impose regulation to control RF emissions and prevent interference with with the other industrial, scientific, or medical equipment. So each company or each country will have their own tolerance limit, and they can allow to certain range only. Okay, more than that they won't allow for the particular country or particular application of usage. Okay, the mechanism of RFID. In a typical system, the tags are attached to the objects. Okay, each tag has a certain amount of internal memory which is used to store information about the object, such as its unique ID number or details including manufacture date and material information. Okay, when a tag passes through the field generated by a reader, normally you can see in any retail shop or any grocery shop, actually they are just running the RFID scanner over the barcode or whatever the product they are having, so it will read that the field message. Okay, so when a tag passes through through a field generated by a reader, it transmits this information back to the reader, which identifies the object. I mean, they can identify the product code, cost, everything can be easily identified using the pattern they are mentioning, check digit, everything. I think already I have mentioned why we are using check digit means to find the accuracy or how the RF scanning was done properly or not. So to just a verification. Okay. Until recently, RFID technology focused mainly on tags and readers, which were being used in systems where relatively low volumes of data are involved. This is now changing. Okay, RFID in the supply chain is expected to generate huge volumes of data, which will have to be filtered and routed to the ERP systems. To solve this problem, companies have developed a special software called Savens. Yesterday I told, right, Savent. I mean, actually I mentioned yesterday as a servant, actually, but it is not. It is a Savent, which act as a buffer between the RFID front end and the ERP backend. So electronic product code. Electronic Product Code EPC is an emerging RFID standard developed by the MIT AutoID Center. It is a RFID version of the Universal Product Code UPC barcode standard. Like UPC, EPC is intended to be used for the specific product identification as well as case and pallet identification. Okay, however, EPC goes beyond UPC. It not only identifies the material but also provides access to the additional data about the origin and the history of the specific batches or the serial numbers. The EPC tag itself identifies the manufacturer, product, versions, and serial number. It's a serial number that numbers that takes EPC to the next level by providing access to the data related to specific units. This allows tracking of specific serialized unit history as it moves through the supply chain. This data may be stored elsewhere, but a standard architecture allows you to access with the more easiness of case. This architecture is known as the EPC network. EPC has now become increasingly important because it is a standard being utilized by the Walmart, Target, Best Buy, and the US Department of Defense in the RFID mandates. Okay, the Walmart, say, well, let's take example for the Walmart RFID mandate. Okay, in June 2014, Walmart announced that it would require its top 100 suppliers to put RFID tags on all the shipping crates and the pallets by January 1, 2005. This would been expand to its next largest 200 largest supplies by the January 1, 2006. Walmart required that each tag should state or store an EPC that would be used to track products as they enter Walmart's distribution center and then in turn are shipped to the individual stores. As the world's largest company in terms of revenue, Walmart mandate has a profound effect on the RFID strategy of many large companies that sought to remain direct suppliers. By 2007, Walmart has found the RFID ability to improve the supply chain was limited by the business partners willing to participate. Walmart targeted suppliers for the RFID program had some of the most efficient supply chains in the industry. And these companies did not initially realize the benefit of the RFID. So then actually at one point of time they understood from the pre-judged or those who already utilize the RF, right, from there they understood the benefit. Okay, Forrester Research calculated the large Walmart suppliers would have to invest more than 9 million to cover costs associated with RFID to achieve the result that Walmart was expecting. Okay, despite the large investment required, many companies have accepted that the increase in the use of RFID will occur in the coming years, and yearly. So, despite the large investment required, many companies have accepted that increase in use of RFID will occur in the coming years, and yearly adoption of the technology is a good business, okay, and I mean strategy. Some Walmart suppliers were quick to comply with the mandate. Procter and Gamble itself is a giant company introduced the RFID policy in its organization with the Walmart mandate as a driver for its own development of RFID. Okay, and other suppliers to Walmart such as Gillette, Kimberly Clark, and Kraft all started RFID projects at the same time. So now let's move on to see the RFID benefits. Okay, supply chain management at a large company such as Walmart or integrated in RFID advances that can achieve visibility of a material throughout the supply chain. Okay, these kinds of benefit are improving with other methods, okay, such as electronic data interchange, that is EDA, barcoding, and advanced shipment notification, ASN, and other benefits to companies lie outside of the supply chain, such as reduction in theft from the store or during transport or storage. We can reduce the theft or we can avoid the theft, and deterrent to the growing problems of product counterfeiting. Both of these issues are costing companies. I mean, I think actually it's a billion in the range of billions of dollars each year. Pharmaceutical companies are increasingly worried about counterfeiting, and RFID tags on each product may help them. However, the level of security needed to combat theft and counterfeiting would require a RFID tag on each product sold. The cost of the tag and of placement of the tag on the product will have to drop significantly for this to be visible. Okay, and in case I mean actually in the late 2007, most of the companies that sell RFID tags do not quote prices because pricing is based on the volume, the amount of memory on the tag, and the packaging of the tag. Okay, the cost of a 96-bit EPC tag is approximately 20 to 40 US dollar cents. Okay, US cents. However, if the tag is embedded in a thermal transfer label on which the companies can print a barcode, the price will rise beyond 40 cents. A transponder is in a plastic cord or a key fob can cost more than $4. Okay, so the RFID things are very cheaper in 2000 early 2000s. Okay, and now we are going to see the difference between the RFID and the barcodes. Okay, the RFID has advantages over the barcodes, but has some disadvantages also that still have to be overcome. Until the disadvantages become insignificant, barcode will still play a part in supply chain and in warehousing. Okay, so each will have some advantages and disadvantages. Okay, when we are talking about advantages of RFID, the RFID technologies does not require line of sight reading, whereas in RF actually you need a line of sight reader has to read that. I mean, a line of sight is required, and here actually RFID does not require line of sight reading. The RFID tag could be read through other materials, whereas barcodes require the line of sight. This implies that RFID reader could read a pallet of mixed pallets, all of which contain individual RFID tags, without having to physically move any of the material or open any issues. If the pallet was full or mixed products, the large number of RFID tags can be read almost instantaneously. The tags would be read sequentially, not simultaneously. Okay, but the reading still could be completed in the microseconds. The data on the RFID tag can be changed or added as a tag passes through a specific operations. So read-only tags are less expensive than the read-write tags. RFID tags are less accessible to poor environmental conditions in which barcode labels become unreadable. RFID tags can be sealed within a plastic enclosure, eliminating many of the problems that a barcodes in harsh environments where they can expose to the chemicals, heat, and other damaging effects. And disadvantage of RFID. Okay, currently cost is biggest roadblock to the widespread use of RFID tags and replacement of barcodes for item level tracking. Barcodes can be produced for a less than 1 cent. Currently, RFID tags cost between 20 and 40 cents for the most basic of tags. Even in the cost falls to several cents per tag, the cost is still significant addition to the cost of an item that is low cost piece of consumer goods. RFID signals can encounter problems when being read through some materials such as metals and liquids. Tag replacement is found to be a greater importance for some materials that are in particular kind of containers, crates, or shrink wrapped pallets. Some case levels some case level RFID tags have to be placed in the specific location on the case, and cases must be stacked in a specific orientation or the configuration to obtain a constraint read from the RFID tag. The ability for RFID not to require a line of sight is also advantage. Okay, a RFID reader will read tags within its range, and this may be problematic if wrong tag is selected. Therefore, the line of sight reading is preferred for some RFID applications. If an RFID tag falls, then it is not as obvious as a failure of barcode. If the RFID tag is not seen, then there is no check to know that a tag is failed. Now we have discussed the basics of RFID. So we can now, I mean, later, I mean, in coming points, actually, we can discuss about the types of RFID tags. So now, when you're discussing about the types of RFID tags, okay, every object is identified in an RFID system will need to have a tag attached to it. Okay, the tags are manufactured in a wide variety of packaging formats designed for the different applications and environment. The basic assembly process involves a substrate material such as a paper, a PVC, etc., upon which an antenna is deposited. Actually, even in government of India has recently taken. I mean, actually, in televisions, people who are watching news and everything, actually, they know actually the RF tag can be pasted or can be injected into the tiger's body, and actually they have some RF sensor attached to some location. Actually, so whenever the number of tigers crossing, so based on the tag attached, the sensor can sense a number. Say they found the population of tigers in particular region or forest in Indian forest. So this will help them to facilitate how much tiger was currently there in the forest. So rather than going to the field and taking manual survey and taking very big risk, this one is very useful. Sensor can track all the tigers, I mean, actually, the tags attached to the tiger so that they can count that exact count of that. And even actually, the repeated counting is not possible because it is having each tag will have some unique code. So based on that, the tigers can be tiger count can be taken. Okay, this is a very useful information as per the, I mean, the wildlife. I mean, count has been made, right? This is very simple. So even actually we can, without going to the field, actually the particular person can track that exact count of that. So the antenna is made from one of many different conductive materials, including silver ink, aluminium, and copper. Okay. Next, the tag chip itself is connected to the antenna using the techniques such as wire bonding or flip chip. Okay. Finally, a protective overlay made from the materials such as PVC laminations, epoxy resins, or adhesive paper may be added to allow the tag to support some of the physical conditions found in many applications such as abrasion, impacts, and corrosion. Okay. Now let's move on to the tag classes. Okay, we have different types of tag classes. That is class 0, read only factory program; class 1, that is write once, read only, that is warm, WORM, that is write once, read only, factory or user program; class 2, read write; and class 3, read write with onboard sessions; class 4, read write with integrated transmitters. So these are some 5 kinds of that. Let us see each one by one in detail. So class 0, read only factory program, right? So I mean, I missed to tell that. So how the tag classes are classified? So one of the main ways of categorizing the RFID tags is their ability or capability to read and write data. Okay, so this leads to the following different classes, 4 classes. Okay, class 0, that is read only factory program. There are simple or simplest type of tags. These are simplest type of tags where data, usually a simple ID number, that is EPC, is written only once into the tag during the manufacture. The memory is then disabled from any further updates. Class 0 is also used to define category of tags called electronic article surveillance, EAS, or anti-theft devices, which have no ID and only announce their presence when passing through an antenna field. Okay, and class 1, write once, read only, WORM, factory or user program, both are applicable. In these cases, in this case, the tag is manufactured with no data written into the memory. Data can be either be written by the tag manufacturer or by the user, but only once. Okay, no further writings or capturing of data are allowed, and the tag can only be read. Okay, Yeah, we can do n number of reading, but one writing can be done only once, either by the user or the manufacturer. Tags of this type usually act as a simple identifiers, okay, and then move on to class 2, that is read write. So this is the most flexible type of tag where users have to access to read and write data into the tag's memory. They are typically used as a data loggers and therefore contain memory spaces than is needed for the simple ID number. Okay, class 3 is nothing but read write with onboard sessions. These tags contain onboard sensors for recording parameters such as temperature, pressure, and motion, which can be recorded by writing into the tag's memory. Because sensor readings must be taken in the absence of the reader, the tags are either semi-passive or active. Okay. Class 4, read write with integrated transmitters. These are like miniature radio devices which can communicate with. So now we are seeing the class 3 rewrite with onboard sessions, right? I already told. These tags contain onboard sensors for recording parameters such as temperature, pressure, and motion, which can be recorded by writing into the tag's memory. Because sensor reading must be taken in the absence of the reader, the tags are either semi-passive or active. Okay, this can be used for well for the industrial uses. Okay, to maintain pressure, temperature, and motions, everything, right? So class 4, that is read write with integrated transmitters. Okay, these are like miniature radio devices which can communicate with other tags and devices without the presence of the reader. This means that they are completely active with their own battery power sources. Okay, and now let's move on to the say the difference between the active and passive tags. Okay, so the first choice when considering a tag is between passive, semi-passive, or active. So passive tags can be read at a distance of up to 4 meter to the 5 meter using the ultra high frequency band, while the other types of tags, semi-passive or active, can achieve much greater distance of up to 100 meter for semi-passive and several kilometers for active. Okay, these large differences in communication preferences can be well explained by the IEEE associations, right? So passive tags use the reader field as a source of energy for the chip and for communication from and to the reader. So let's say actually these are the electronical parts, but I think actually it is good to know for SAP consultants while implementing RFID technology, okay, in their client space. So the passive tags use the reader field as a source of energy for the chip and for communication from and to the reader. The available power from the reader field not only declines very rapidly with the distance but is also controlled by the strict regulations, resulting in the limited communication distance of 4 meter to 5 meter when using the ultra high frequency band of 860 MHz to 930 MHz. Okay, semi passive or battery assisted tags have built-in batteries and therefore do not require energy from the reader field to power the chip. This allows them to function with lower signal power levels, resulting in greater communication distance of up to 500 meters. Distance is limited mainly due to the fact the tag does not have integrated transmitter and still must use the reader field to communicate back to the reader. Active tags are battery powered devices that have active transmitters on board. Unlike passive tags, tags generate RF energy and apply it to the antenna. So internal power source is there. Okay, this is autonomy from the reader means that they can communicate at a distance of several kilometers or more than that. So the experience gained by the different companies running various trials and evaluations has been so far that out of the different RFID frequencies, low frequency, high frequency, ultra high frequency, and the microwaves, high frequency and ultra high frequency are the best suited to supply chain. Okay, so furthermore, right, it is expected that ultra high frequency because it's superior read range will become the dominant frequency. Okay, and this does not mean, however, the low frequency and microwave will not be used in certain cases. Okay, so that's what the conclusion. Okay. Um, so we have different RFID frequencies, that is LF, HF, UHF, and microwave. Okay, HF and UHF are best suited to the supply chain. Okay, that is important thing. So current uses of RFID. Okay, so now actually we are moving to the current usage of RFID. So the RFID technology is already well established in a number of areas such as electronic payments, supply chain management, and livestock tracking, as well as previously unforeseen areas such as data conveying everything. So electronic payments. Okay, so what RFID will do in electronic payments, right? So in many countries, small cards based on RFID technology are becoming more common in transport situation. Hong Kong introduced the Octopus system in 1997, and it is now used by more than 95% of the population in Hong Kong. The Oyster card, okay, a transporter for London, TIL, okay, contactless ticketing, okay, scheme, okay, is a smart card. Okay, the transporter for London, that is TAL, estimate that 1 million fewer transactions per week are made at a ticket offices, and there is a 30% improvement in the speed of the passenger passing through the ticket gates. Okay, it is more difficult to copy Oyster cards than it is a copy of the magnetic strip cards, and because of each card contains unique ID number, it can be immediately cancelled if the card is reported lost or stolen. So retail stores. So large retail companies are pushing the adoption of RFID tags as a way of achieving supply chain visibility, reducing theft and product counterfeiting. These companies see RFID technologies as a way of preventing out of stock occurrences, the overstocking of the products in the warehouse, and the theft or the loss of goods. Okay, for insurance, the total cost of crime, including crime preventions for UK retailers, was 2.25 billions in 2002. Marks and Spencer's tagged 3.5 million returnable food goods delivery trace in 2002. This is among the largest supply chain operations involving RFID in the world. Okay, the tagged trays are filled with individual food items at the supplier, carried by the distributor to the shop, emptied and then returned. The information on the tag tray is read at each distribution point, resulting the improved food delivery logistics and fresher food in stores. Okay, individual product tagging. So retailers are already looking at the tagging of the individual products to allow for better control of the products, recalls, and better targeted marketing campaigns in the United Kingdom. The retail store Tesco undertook a RFID trial at one store in 2003, which involves a tagging individual DVDs. RFID readers were built on into the store shelves to monitor each item. Not only was the stock room um, I alerted when a shelf needed in restocking, but stuff were alerted when browsing customers replayed DVDs in the wrong section. Okay, part stocking. So Virgin Atlantic Airways, everybody knows, right, has introduced RFID as a project to track critical high-value aviations assets moving through its logistics supply chain at the England's Heathrow Airport. Okay, the aim is to track and trace high-value repairable aircraft parts, often at a short notice. Virgin tags serviceable airplane parts that pass through its Heathrow warehouses. Okay, when an item enters the warehouse, employees use a desktop computer to enter the item into the aviation maintenance and parts inventory tracking system the airline already using. The next stage is a full inspection of the part. If it passes the inspection stage, the part is given to the goods receipt number, which triggers the generation of RFID label. So Virgin Atlantic employees then attach the label to the container holding the part. Okay, they also attach a tag to the to a storage bin. Okay, once the container and the storage bin are tagged at the warehouse entrance and inspection area, the items and bins are either placed on a storage racks or sent out of the warehouse for immediate use of the on an airplane. So this video examine the current commercial use of RFID technology. Okay, so RFID and SAP. So SAP currently offers RFID solution called SAP AutoID infrastructure AI. This is a part of SAP business suite similar to the SAP supply chain management SCM and integrates SAP with RFID. Okay, SAP AI can be implemented either as a standalone system or can be integrated in the supply chain functions. Okay, so we have many release, and actually we already saw AI 4.0, SP03 and everything, right? So that will help you to understand the basic concept. And actually yesterday I discussed about the supported functions of AI, right? Outbound processing, that is slap and ship, and then flexible delivery processing, generation of pedigree notifications, and returnable transport items processing. Okay, I think actually the slap and ship I already told. Slap and ship is an approach to complying with the customer requirements for the physical identification of materials shipped through the outbound process. The main goal of the slap and ship strategy is to invest the minimum amount of capital into the RFID implementation needed to comply with the mandates set forth by both Walmart and the Department of Defense. And I have told flexible delivery processing, right? That allows automation of outbound processing and inbound processing. It is just a recap of this earlier video. Okay, create outbound delivery in the ERP system, pack and unload the outbound deliveries in SAP AutoID infrastructure, post goods issue in the ERP system, send advanced shipping notifications, create inbound deliveries in the ERP system, unload inbound deliveries in the AutoID infrastructure, post goods issue in the ERP systems. Okay, these processes are particularly suitable for current RFID technology and for the goals of great many retail customers. Okay, and now actually yesterday we have not seen the generation of pedigree notifications in medical field, right? During the counterfeiting has become a major problem for the pharmaceutical industry, and it is estimated to a cost of $46 billion a year in the lot of profits. Okay, although the drug counterfeiting is relatively rare in the United States, the amount of counterfeit pharma from the overseas has increased in recent years. The US Food and Drug Administration (FDA) believes that RFID will work effectively to fight drug counterfeiting. The FDA's Counterfeit Drug Task Force has been investigating RFID technology and the concept of electronic pedigree called e-pedigree, a procedure that records where the drug is manufactured and how it's delivered. That is called e-pedigree. The adoption of RFID as the case and the pallet level would help secure the integrity of the drug supply chain so that pharmaceutical companies can reliably provide greater assurance that the product was manufactured and distributed safely. Many drug manufacturers such as Pfizer, Purdue Pharma and GlaxoSmithKline and have introduced RFID drug pedigree projects. Okay, the drug pedigree system will authenticate pharmaceuticals as a legitimate throughout the supply chain. The system uses RFID to match each container which is corresponding to pedigree. During the manufacturing or at any time prior to the distribution, RFID tags can have randomly generated code written to chip or an already embedded code used to identify the product. This code is unique to a product at one or more levels of the packaging. Okay, it is stored along with the related data and is thereby available for authentication. At the stages in the movement of products, a tag would be scanned to create a digital record of many transactions. When the material reaches stores, ready for sale to consumer. A complete record of the distribution would have been created and stored. And SAP AutoID infrastructure enables a generation of pedigree notification. These XML messages contain information that can be used by the third-party vendors to create a pedigrees that satisfy the state legal requirements. Pedigree notification provide data recording, okay? That is manufacturers, that is example name, address, state license number, drug, that is in drug actually we have the name of the drug, dosage form, dosage strength, container size, expiration date, lot number and ID, okay? And trading partner, example name and address, and person who should certify the delivery of the receipt of drug. I mean example name, address, phone number and email, and date of transaction. So more data may be available for the pedigree notification in future SAP releases. Okay, and returnable transport packaging. I already told the returnable transport RTI or the assets that can be identified if they are allocated via with a tag encoded with the global returnable asset identifiers. Okay, GRAA already told. A returnable transport items or assets is one that is delivered by the owner to custody of another business entity, usually for a fee, right? RTI processing includes the functions such as manage, load and unload RTIs filled with the products or with other RTIs, track the current location of an RTI and evaluate the stock and cycle times, achieve transparency across the stocks of RTI, and automate process, reduce stocks, shorten cycle times and recognize bottlenecks. Okay, the GRAI provides a unique identification for an asset. It uses a prefix assigned to the companies by the Uniform Code Council (UCC) to develop, assign and maintain a unique asset number for the equipment, resources, supplies, etc. in order to track the location. Okay, therefore GRAA is a unique code that is specific to the assets. The EAN identification number of a returnable asset, right? GRAA is defined as a physical item with no reference to the contents. The EAN ID of a returnable asset enables tracking as well as recording of all the relevant data. Returnable assets such as pallets, barrels, rail cars, and trailers for further use in transport and trade process become increasingly important. The main focus is to manage returnable assets within the harmonized business process and leverage the EAN system in the unique identification of assets. Okay, so now we have discussed about the RFID applications available in SAP. So let us summarize the points we discussed earlier. Okay, radio frequency identification technology has recently become commercial and technology viable. RFID tags are essentially microchips that act as a transponders, always listening for the radio frequency signal sent by the RFID readers. When transporter receives a certain radio query, it responds by transmitting its unique ID code back to the transceiver. Most RFID tags do not have batteries. Instead, they are powered by the radio signal requesting a reply. So RFID can be used in warehouse after large corporations such as Walmart, Target, and all other companies, Reliance, right? So as a mandate, the use of RFID, many companies have been investigating RFID for tracking the movement of materials, inventories, that is entire end-to-end. Although they may not reach the level of pedigree systems proposed by the FDA, Food Development Association of USA, they can expect to improve the visibility of the material through the supply chain. So the Auto ID infrastructure, SAP AI, right? Solution is available for companies that wish to use RFID with their ERP systems. SAP AI requires configuration for interaction of RFID process with ERP functions. At the cost of the RFID tags and the reader falls, we can look forward and to the usage of RFID and the need for a more integrated RFID. Okay, so definitely actually the points whatever I discussed, right, actually about the RFID technology, the mechanism RFID, and then say the RFID benefits, and then the the RFID differences with the barcode, advantages and disadvantages of RFID, RFID tags and tags classes, active and passive tags, current uses of RFID, and tag class we have four based on the capacity of use in the RFID. And then recent use of RFID, that is electronic payment, retail stores, individual product tagging, parts tracking, pedigree, that is called e-pedigree. All this can be achieved with the RFID technology. So I think actually the video details I have shared here will be more useful to each and everyone. Thanks for watching my video. This is Shivakkumar signing off. Thank you.